The Great Pyramid of Giza is made of approximately 2.3 million stone blocks. Each block weighs on average 2.5 tons. Some of the blocks in the interior weigh up to 80 tons. The entire structure was built to such precise mathematical tolerances that the four sides of its base differ from each other by less than 8 centimeters across a total length of over 230 meters. It was built over 4,500 years ago. And for most of recorded history, nobody could fully explain how. Not the medieval scholars who wrote about it, not the explorers who measured it, not the engineers of the 19th century who tried to reverse engineer it. For thousands of years, the most honest answer to the question of how the pyramids were built was simply, we are not entirely sure. That answer is finally starting to change. And what modern archaeology and engineering have pieced together is a story far more fascinating than any mystery or conspiracy theory ever was. Let us start with the most basic question that people get wrong before anything else is discussed. Who actually built the pyramids? For a very long time, the popular answer was slaves, specifically Israelite slaves as described in biblical accounts. This answer turns out to be almost certainly wrong, and the evidence against it came not from historical texts, but from the ground itself. In the 1990s, archaeologists discovered a massive workers' village near the Giza Plateau, buried and preserved over thousands of years. Inside were bakeries capable of producing enormous quantities of bread, breweries, medical facilities, showing evidence of surgical care, including successful amputations and bone healing, and tombs, proper burial sites with offerings, built for the workers who died on the construction site. Slaves in the ancient world were not given proper burials. They were not given medical care. They were not fed industrial quantities of high-quality food. The evidence from the workers' village points overwhelmingly to a paid, organized, skilled workforce, probably rotating in teams from across Egypt, working in shifts, receiving wages in the form of food, beer, and goods. Building the pyramid was not a punishment. For many Egyptian workers, it appears to have been a source of genuine pride now. Now here is the question that actually stops engineers in their tracks. Even with an organized, willing workforce, how do you move a 2.5-ton stone block? The ancient Egyptians had no wheel in the early pyramid period. They had no iron tools, only copper chisels and wooden sledges. They had no pulleys as we understand them. What they had was an extraordinary understanding of simple physics, massive human coordination, and a resource that most people completely overlook. The Nile River. The quarrying process began far from Giza. The limestone used for most of the pyramid's bulk came from a quarry just across the Nile. But the higher quality white limestone casing stones came from Tura, roughly 13 kilometers away by river. The granite used for the internal chambers came from Aswan, over 800 kilometers to the south. Moving these stones was not done by brute force alone, it was done by water. The Nile floods every year, and ancient Egyptian engineers used this flood season strategically. During the inundation period, when the Nile overflowed its banks and created a vast shallow water surface across the floodplain, barges loaded with stone could float enormous weights across terrain that would have been impassable on land. Harbours and canals were built specifically to bring the stones as close to the construction site as possible during these flood periods. Recent archaeological discoveries near Giza have confirmed the presence of ancient harbour infrastructure, essentially proving this water transport theory with physical evidence. But the stones still had to travel the final distance across dry land and up the pyramid itself. This is where the sledge comes in. Experiments and ancient wall paintings have both confirmed that large stone blocks were placed on wooden sledges and pulled by teams of workers using ropes. The key detail that nobody understood for a long time was how they reduced the friction enough to make this practical. An ancient Egyptian tomb painting discovered in the early 20th century showed the answer: a worker at the front of the sledge pouring liquid, almost certainly water or a slippery plant-based liquid, onto the sand directly in front of the runners. Modern physics experiments have tested this exact technique, and found that wet sand under a wooden sledge reduces the required pulling force by roughly 50%. The entire operation suddenly becomes plausible, with a large enough workforce and a reliable water supply, both of which ancient Egypt had in abundance. Getting stones to the base of the pyramid is one challenge. Getting them up the pyramid as it grows taller is a completely different problem, and one that researchers have debated intensely for decades. The most widely discussed theory involves ramps along earthen or mud brick ramps that workers pulled sledges up to reach progressively higher levels. The problem is that a straight external ramp, long enough and shallow enough to be practical for 2.5-ton blocks, would have needed to be almost as large as the pyramid itself to maintain a workable slope as the structure grew taller. Some researchers have proposed a spiraling ramp wrapping around the outside of the pyramid, which requires less material but creates navigation and corner turning problems for heavy sledges. A third theory, proposed in 2007 by a French architect named Jean-Pierre Houdin and gaining significant attention from engineers, suggests an internal spiral ramp was used for the upper 2/3 of the pyramid, visible today as slight notches in the corners of the structure when examined with infrared scanning technology. No single ramp theory has been definitively proven, and it is increasingly likely that the Egyptians used different systems for different stages of construction external ramps for the lower sections where the angle is manageable, and a different method for the upper portions. What makes the pyramid construction story genuinely extraordinary is not the brute force, but the organizational intelligence behind it. Managing a workforce that historical estimates place between 20,000 and 30,000 people, coordinating the quarrying, river transport, land transport, cutting, and placement of millions of stone blocks across a multi-decade construction project, feeding and housing that workforce, maintaining quality control precise enough to achieve near-perfect alignment to true north. This was a logistical achievement on a scale that had never existed before in human history. The pyramid was not just a building, it was a project management system, a supply chain, a city of its own. The engineering was remarkable. The organization behind the engineering was perhaps even more remarkable. There is one detail about the Great Pyramid that rarely comes up in popular discussion, but stops every engineer who hears it cold. The pyramid is aligned to true north with an accuracy of just 0.067 degrees. Modern GPS-assisted construction barely improves on this. The ancient Egyptians achieved this alignment without any instrument we have yet identified as a precision north-finding tool. The best current explanation involves a technique using the circular motion of stars around the celestial North Pole, tracking the rising and setting point of a specific star over multiple nights and bisecting the angle to find true north. It works. It can be done with nothing but patient observation, wooden sighting tools, and mathematical understanding. But doing it accurately enough to align a 230-meter structure to within a fraction of a degree required an astronomical knowledge and observational precision that most people in the modern world do not give ancient Egyptians credit for possessing. So the next time someone tells you the pyramids must have been built by aliens or lost technology or some civilization we have not discovered yet, here is the real answer. They were built by human beings who were exceptionally well organized, deeply intelligent, and operating with a level of mathematical, astronomical, and engineering knowledge that we are only now beginning to fully appreciate. They had no machines. They had water, wood, rope, copper, mathematics, and tens of thousands of people who were motivated, fed, and coordinated by one of the most powerful administrative systems the ancient world had ever produced. That is not a lesser achievement than using machines. In many ways, it is a greater one.